Okay, so we described the longitudinal or the anterior view of longitudinal anatomy of the spinal cord. Now we're going to slice the spinal cord. Okay, so you have again here your vertebral column. Within the vertebral column, in the vertebral canal, which is this, you have inside your spinal cord in blue in here. Okay, so we're going to section this, a transverse section, and look how it looks like. It looks like a butterfly. So that, I'm going to take it and I'm going to put it, no, there. Okay, this is what we're seeing. This is just zooming into this section view, this cross section of the spinal cord. So we're going to see, well, there are two things that jump to your eyes, right? One is that one structure is gray and the other one is white. So this with the shape of a butterfly, or at least that's how anatomists see this, that's the gray matter of the spinal cord, and surrounding that is the white matter of the spinal cord. So now remember, what do we have in the gray matter? We have the bodies. I have said this like 20 times. Maybe this is the number 23rd time I say this. So the cell bodies of the neurons, the dendrites, and maybe some short unmyelinated axons. What are we going to find in the white matter? Fibers. This is a transverse section, so these are transverse sections of all the axons that are going up and down through the spinal cord, okay? And these axons are covered by myelin, so these are myelinated axons, okay? So gray and white matter, done. This is central nervous system. Okay, let's describe the gray matter in black. Let's put it in black. Okay, in the gray matter we have, you can see these three projections. One anterior projection, well, all of this, which is a horn. Okay, there's another one in here, and not in this section. I know that this slice of spinal cord is not taken from this. What type of vertebrae is this one? Cervical, thoracic, lumbar. It's a thoracic vertebrae. Now, on the thoracic segments of the spinal cord, and only in there, and we will understand that the why of this on the next chapter, but only in there we have another horn. Again, this is only on the thoracic segments. So we have an anterior horn, a posterior horn, and the lateral, and just for the sake of, labeling everything correctly, is gray horn. So anterior, lateral, and posterior gray horn, same thing is going on the right side. How do I know that this is anterior and this is posterior? Well, can you see these lines, or those are like invaginations deep to the spinal cord? Well, the anterior one is always more deeper and wider than the posterior one. And this one is called the anterior median fissure. Remember, a fissure is a deep groove. And this one that is not that wide, we call it posterior. You can, in here, sometimes they use the term posterior or dorsal, and anterior and ventral interchangeably. So posterior median sulcus. Posterior median sulcus, anterior median fissure. In the gray matter, we have anterior gray horn, lateral gray horn, posterior gray horn. What do we have in the white matter? Instead, what do we have in the white matter of the central nervous system? All of these axons bundle up to form a, not nerves, because nerves are in the peripheral nervous system. In here, they form tracts, okay? And that's how one way to call them. Or we can call them tracts, we can call them column funiculi, another name. So this is the anterior, the lateral, and the posterior white column or white funiculus. Okay? Done with that. We described and we labeled the gray and the white matter of the spinal cord. Remember, still nervous system. Now, let's describe the neurons that we're going to find in here. Let's use red. Okay. In the posterior gray horn, we are going to find interneurons of sensory, somatic, and visceral in several places, interneurons. Okay, so these are sensory interneurons. Okay, now remember, please, that first of all, interneurons are only present in the central nervous system. And second, remember I told you all the sensory information comes from posterior, from your back, and all the motor commands exit anteriorly. So this is the way of flow of information in the central nervous system. So that's what we have so far. Sensory, somatic, and visceral interneurons in the posterior gray horn. In the lateral gray horn, and in the, I'm getting out of colors in here, in the anterior and in the lateral gray horn, we have motor neurons. The thing is that these are visceral motor neurons, and these ones are somatic motor neurons. Do you remember the difference, right? If not, go back to the beginning of the chapter. Somatic, skeletal muscles, visceral, cardiac, and smooth muscle. Okay? So we have our 4 divisions right in here, as you can see. We describe. In here, there's the sensory motor, the sensory somatic. Okay? Here, the visceral motor, and the... What did I put here? Oh, sorry. Sensory visceral, sensory somatic, visceral motor, and somatic motor neurons. Okay? Now, there is one structure that is not part of the spinal cord. It's not part then of the central nervous system. As you can see, I'm outside the spinal cord. And this structure, I'm gonna paint it like that. And okay, and is connected with this. Okie dokie. Now, I'm going to follow all the sensory is going to be red. All the sensory. Okay. This structure is not new for you. It's outside, it's in the peripheral nervous system. But it's not new for you. You remember that this is the dorsal root ganglion, where the unipolar neurons, sensory neurons, these are my sensory neurons are, right? So this neuron, remember, is connected with, let's put in here the hand. Oh, beautiful hand. Okay, and it branches in there, that sensory neuron, or connects with the receptor and is detecting or sensing, let's say, touch. Okay, so I feel that sensation, it travels all the way following this direction to, this is a sensory or afferent fiber, right? Somatic fiber, because it's in the hand, gets to the neuron, the sensory body, the body of the sensory neuron located in the dorsal root ganglion. That's the name of this structure. Let me write it really fast for you. This is dorsal or posterior, dorsal root my gosh, ganglion. Believe it or not, that's an A. Ganglion. Okay, looks like a preschooler doing this. Now, okay, we're right here in our sensory neuron on the dorsal root ganglion. Then this information keeps going on, remember? Following the same direction and enters into the posterior gray horn of the spinal cord. In here it meets these interneurons, which are, well, in this case, are going to be these interneurons, somatic sensory, because the sensation is coming from the skin. So this sensory neuron synapses with an interneuron located here in the posterior gray horn, okay? And this is how the sensory information gets finally into the spinal cord. Now, this structure in here, I'm gonna still use again the green. These are called roots. Actually, sorry, not there. Here. Roots. Oh man, not rot, roots. Okay, this is the dorsal, because we are in the posterior. You can call it posterior. I don't know why in this side it doesn't write that well, but this is the dorsal or posterior root. Okay. Now let's go and describe the motor cells, the motor neurons. Every motor command exits the spinal cord anteriorly. Remember? So if it's coming from a visceral, if the order for contraction is going to be given to a visceral organ, to the heart, or to a smooth muscle, or to the gland, adipose tissue, whatever, is going to come from the lateral, the neurons, the visceral motor neurons located on the lateral gray horn of the spinal cord that are located only on the thoracic segments. Okay? Now, if let's say that I'm going to innervate actually a muscle located on the hand as well, a skeletal muscle, is going to follow a somatic motor neuron. Okay? So the somatic motor neuron, the axon of the somatic motor neuron exits following the anterior root now of the the anterior root, and that's it so far. The anterior or root. I was going to write dorsal. So the anterior or ventral root. Okay, so this part that we are forming right here, okay, now we are right here at the level of the intervertebral foramen, okay, we are forming, this is your spinal nerve. Spinal nerve. As you can see, the spinal nerve, and we're entering, see how difficult it is to separate central from peripheral nervous system. They're so linked together that we cannot separate their explanations. So the spinal nerve carries, or they're called mixed because they carry both sensory fibers that are delivering or carrying information from the receptors to the spinal cord, but also they are carrying motor fibers or motor axons that are delivering motor commands from the spinal cord to the effector. Let's say that the effector in here is a muscle in the hand. Okay, and then we will describe in next chapter how this spinal nerve branches into rami. Okay, an anterior and a posterior ramus. Is this clear? I think that's it. This is all I wanted to explain to you. It went faster than I thought it will, but that's what it is. Okay, so your sensory, your sensory neurons located in the dorsal root ganglion. Remember, ganglion is a group of neuronal cell bodies in the peripheral nervous system. If we find the same structure right in here, let's say, we're going to call it a nucleus. Okay? Now, this is a spinal nerve, which is a bundle of axons in the peripheral nervous system. This bundle of axons that I can see here in the central nervous system, I call it tract. Okay? So I hope these concepts are clear. In the next video, I just want to put together all of the information that we have covered so far in these 2 chapters of nervous system. It's going to be fast. It's just to explain the pathway in general, put everything together. Got it? See you.